Hello students, today we are going to study two very important topics of probability. These are law of total probability and Bayes theorem. Before discussing about the two topics, let me take one situation. The situation is we are having two bags, bag 1 and bag 2. Let us say bag 1 has 3 white and 4 red balls. Bag 2 contains 2 white and 5 red balls. Now the situation is like, first of all we need to select one of the bag. So the case may be like we can select bag 1 or bag 2. Let us suppose we have selected bag 1 in the trial. So this is the whole sample space containing the two bags, and out of these two bags let us select bag 1 which is containing 3 white and 4 red balls. Now the next step is we need to select a ball, we can say, let us say white ball, from the selected bag. So let us select one white ball from this bag, means the bag which we have selected in first experiment. So let us draw white ball. Now how will you find out the probability of this white ball? Let us discuss about it. According to the experiment, we have two bags and we need to select one bag out of these two. So the probability of selecting these two bags is equal, that is 1/2 for each bag. So therefore let us say that PE1 is the event of selecting first bag, which we are having as 1/2, and similarly it is for PE2, where E2 is the probability of selecting second bag. Now from the selected bag we need to draw a white ball. So as we have done in case of conditional probability, the condition is here, let us think, bag 1 is selected. If bag 1 is selected, if bag 1 is selected, and let us say let A be the event of selecting white ball, then as we have done in case of multiplicative law of probability, that PE1 is equal to 1/2, and out of this event, means after happening of PE1, the probability of white ball will be 3/7. So therefore for selecting white ball from first bag will be 1/2 into 3/7. But the case may also be that second bag is selected. So the second case may be if bag second is selected, because when we are selecting the bag, so either 1 or 2, any of the bag may be selected, and the same A is the event of selecting white ball, then this probability can be written as 1/2 into white ball from second bag, it is 2/7. So into 2/7. But the two cases are happening in the same experiment. So the probability of getting white ball, probability of getting white ball in whole process is 1/2 into 3/7 plus 1/2 into 2/7. Means first bag is selected, then probability of selecting white ball from this bag. Second case, if second bag is selected, then probability of selecting white ball from this second bag. So in this way, we can find out the probability of selecting white ball in this situation. Now, if the question is like, find the probability that the ball drawn from a particular bag, if the color of the ball is given, let us say selected ball is let me say red, then what is the probability that this ball is selected from any one of the bag? Let me say bag second. So have you understood the situation? In first situation, the first case was selecting the bag, and then we need to find out the probability of selecting the ball of any of the color from the selected bag. But in this case, the situation is reverse. It is given that a particular color of ball is selected. Now we need to find out that this selected colored ball is from a particular bag. So this situation is calculated by using reverse probability. And this reverse probability formula to find out probability of such kind of situation is given by Bayes. So therefore this formula, or you can say theorem, is known by the name Bayes theorem. And the first case is the case of law of total probability. So the law of total probability and Bayes theorem are the reverse cases of each other. So first of all, let us discuss what are the conditions for the events that we are discussing in total law of probability and Bayes theorem. So for that, we should know one term called partition of a sample space. To understand the partition of a sample space, let us take events let me take event E1, E2, E3 up to En. And these n events are said to represent a partition of sample space if these events satisfy the following three conditions. Number one condition is E1 intersection E2, E1 intersection E3, E2 intersection E4, and so on. Or we can say if I and j are having the values 1, 2, 3 up to n, then ei intersection ej is equal to phi. Here these are also equal to phi. Meaning of this is that these events are mutually exclusive events. Let me recall exclusive events to you. Exclusive events are the events which have nothing in common. Means the intersection of these events is phi. So therefore, if the events are mutually exclusive. The second situation is E1 union E2 union E3 up to union En is equal to S, means equal to sample space. And if you remember, such type of events are called exhaustive events. So it means the given events are mutually exclusive, number one, number two, exhaustive, and number three, these probability of these events is non-zero, or you can say PE1 is equal to PE2 is equal to PE3 up to PEN are non-zero, or you can say greater than 0, and you know very well it should be less than or equal to 1, but it should not be 0. So if two or more events satisfied these conditions, then these events are said to represent a partition of sample space. For example, you can take let E and E naught are said to represent partition of sample space. Why this is so? Because E intersection E naught is equal to 5. Nothing is common out of these two. First condition gets satisfied. Second condition is E union E naught is equal to sample space. And the third condition, we know that PE is equal to PE naught. PE naught is non-zero, or you can say greater than 0. So therefore, as these two satisfy this condition, therefore these are said to represent partition of a sample space. Or you can take more examples these are the two events E and F. This portion is only E, or you can write it as E intersection F naught. This portion is E intersection F, and this portion is F intersection E naught. This Venn diagram I explained in my previous video as well. So three events, let me name this as event A, this as event B, and this as event C. So these A, B, C events are again said to form a partition of sample space because all three A, B, C are mutually exclusive. Nothing is common because one is this portion, another is this portion, and third one is this portion. So all are mutually exclusive. Number two, if we combine the three, means find out union of these three, A union B union C, then whole sample space is as the result. And third one, that PA, PB and PC are non-zero. So therefore, these can also be called to form a partition of sample space. Now let us come to know about the statement of law of total probability. Law of total probability states that if E1, E2 up to En are the events which form partition of sample space, then the occurrence of an event A which is associated with the sample space S, in which we are having E1, E2, E3 up to so on, then this occurrence is given by PA is equal to PE1 into PA by E1 plus PE2 into PA by E2 plus PE3 into PA by E3 up to so on. And this is nothing but simply, as I just explained in the example, that one of the event has happened and then conditional happening of another event is multiplied by the previous occurrence of the event. And this can be given by the addition of such events which are mutually exclusive, exhaustive, and having their probabilities as non-zero. Now let us discuss Bayes theorem. As I make you understand in the example that PA is the event when first of all E1, E2 or any of the event En is happening, and after that we are calculating the happening of event A. But if we need to find out that corresponding to which event this event A is happening, then we will use Bayes theorem. And Bayes theorem states that P EI upon A. The meaning of EI upon A is this may be E1 upon A if the event A is happened due to or corresponding to event E1. It may be E2, it means event A is happening corresponding to event E2 and so on. So means this I is 1, 2, 3, 4, 5 up to N is equal to P EI into P A by E1, or you can say EI upon the addition of all these, means P E1 into P A by E1 plus P E2 into P A by E2 plus up to so on, or in general we can write it as P EI upon A is equal to P EI into P A upon EI upon summation of J is equal to 1 to N P EJ into P A by EJ, where I and J is equal to 1, 2, 3 up to N. Now let me take some examples to show that how to use these two formulas in problems. Let me discuss this example. It is a bag contains 2 white and 5 black balls, and another bag contains 4 white and 4 black balls. First of all, let me draw the bags. There it is first bag and there it is second bag. First bag contains 2 white and 5 black balls. This is first bag. And second bag contains 4 white and 4 black balls. Then next is one bag is chosen at random. So as I discussed earlier that any one of the bag may be selected, either bag 1 or bag 2. Let us say that E1 is the event of selecting first bag and E2 is the event of selecting second bag. So one of the bag is selected and from the selected bag one ball is drawn. If bag 1 is selected, then a ball is drawn from bag 1, and if bag 2 is selected, then a ball is drawn from bag 2. Find the probability that ball drawn is white, means we need to select white ball from the selected bag. Let us consider that A is the event of selecting white ball from selected bag. So first of all we need to calculate PE1 and PE2. So as the chances of selecting of the two bags is equal, so therefore we can write PE1 is equal to PE2 is equal to 1 by 2. And clearly these E1 and E2 are mutually exclusive and exhaustive events, because E1 intersection E2 is equal to phi and E1 union E2 will from the total sample space, as well as the probability of any of the event is non-zero. Therefore, we can apply here total law of probability. Now, we need to find out PA by E1. So, what is the meaning of PA by E1? PA by E1 is selection of white ball when bag E1 has already selected. So, this is nothing but simply the conditional probability of selecting white ball when E1 has already happened. So, which is equal to 2 upon 7, because in bag 1 we are having 2 white ball and 7 as the total ball. Similarly, now you can find out A by E2, that is selection of white ball when bag E2 is selected or event E2 has happened. So it is 4 by 8 clearly. Now we need to find out PA, means selection of white ball. So it is clearly P E1 into P A by E1 plus P E2 into P A by E2. You know this thing, that this is what? This is multiplicative law of probability. So now we need to just put the values. PE1 is 1 upon 2, A by E1 is 2 by 7, plus PE2 is again 1 upon 2 and PA by E2 is 4 upon 8, that is 1 upon 2. So after simplifying this thing, you can find out the probability of selecting white ball from the selected bag. Now let me reverse the situation by writing the question as, in this problem we are having a bag contains 2 white and 5 black balls and another bag contains 4 white, 4 black balls. I have taken the same problem as I have taken above. Only one change I have made here. It is one bag is chosen at random. From the selected bag, one ball is drawn. If this ball is found to be white, then find the probability that it was drawn from first bag. Means here we need to find out reverse probability. It is given that the ball drawn is white. Now we need to calculate that this white ball is from bag 1. So here when we need to use reverse probability, then we need to use Bayes theorem. We will attempt the question in the same way as we have done over here. Means we need to show the 2 bags, then we'll define what is E1, what is E2 and what is A. PE1, what is PE2, and then A by E1, A by E2. Then we need to calculate PE1 by A, means the ball selected from first bag. Means again we need to use conditional probability, like probability of drawing white ball from bag 1, or we can say drawing a ball from bag 1 when this ball is white. So if we use Bayes theorem over here, as I told you, we'll use the formula PE1 into PA by E1 upon PE1 into PA by E1 plus PE2 into PA by E3. Now let us put the values. PE1 is 1 upon 2 and PA by E1 we have calculated in the above example as 2 by 7. Next is 1 upon 2 into 2 by 7 plus PE2 is 1 upon 2 and A by E2 we have calculated 4 upon 8. So after simplifying this thing, we will be able to get the required result. Now let us take another example. It is, in a bolt factory, machines A, B and C manufacture 25%, 35% and 40% of total bolts respectively. Of their output, 5, 4 and 2% are respectively defective bolts. A bolt is drawn at random from the product. What is the probability that bolt drawn is defective? Here directly the probability of defective bulb is asked. So therefore This is the problem of total law of probability. And we'll move in the same way. Let E1 represent event of selecting bolt from machine A. So we'll write it over here. E1 is the event selecting bolt from A machine. E2 is the event of selecting bolt from B machine, and E3 is the event of selecting bolt from C machine, and A is the event of selecting defective bolt. Selecting defective bolt. So first of all, let us calculate PE1. As it is given that first machine manufactured 25% of the total product. So therefore, if we select bolt from machine A, then it is having probability as 25 upon 100, or we can say 1 upon 4. Similarly, PE2. Machine B is producing 35% of bolts. So means the selection of bolt from machine B is 35 upon 100, and from machine 3, that is PE3, is 40 upon 100, because C machine is manufacturing 40% of bolts. Now we'll calculate PA by E1, means selection of defective bolt from machine A, and it is given clearly that 5% of defective bolts are from machine A. So means if we are selecting defective bolt from machine A, then clearly 5% will be defective bolts. So means this is 5%, or we can say 5 upon 100. Similarly, PA by E2 is selection of defective bolt from machine B, and this is given 4%, and PA by E3 is given to you as 2%. Now we need to calculate PA, means the selection of defective bolt. So this is PE1 into PA by E1. First case means when bolt is selected from machine A and then a bolt is selected from it, plus PE2 into PA by E2, plus PE3 into PA by E3. So any case may happen out of these three. That's why we'll add all these three, which is equal to PE1 we have 25 upon 100, and PA by E1 we have 5 upon 100, plus PE2 we have 35 upon 100, and A by E2 is 4 upon 100, plus PE3 is 40 by 100, and PA by E3 is 2 by 100. This is E3. So after calculating the value, we can find out the required result. Now let me write this question in another way. In this problem, I have taken the same problem as above. Only the change that I have made is a bolt is drawn at random from the product and is found to be defective. What is the probability that bolt drawn is manufactured by machine B? So means again it is the case of reverse probability. Means we need to apply Bayes theorem. Here we have considered that E2 is the event of drawing bolt from machine B. So it means we need to calculate P E2 by A. Means selection of defective bolt from machine B. So which is equal to P E2 into P A by E2 upon sum of all three, that is P E1 into P A by E1 plus P E2 into P A by E2 plus P E3 into P A by E3. So let us put the values. P E2 we have calculated 35 upon 100 and P A by E2 we have calculated 4 upon 100 divided by P E1 that is 25 upon 100 into 5 upon 100 plus 35 upon 100 into 4 upon 100 plus 40 upon 100 into 2 upon 100. Therefore, from the above discussion, it is clear that in both the questions, a little difference of the statement you will find, and if you read the question carefully, you can identify that the given question is from total law of probability or from Bayes theorem. So be careful, read the question carefully, and then easily you can attempt these questions. And these questions are very important from the point of view of examination, because usually a 4 or 6 marks question is there in the exam. So keep learning and stay tuned.